A good day to everyone who's watching. In our lesson of algebra today, we are going to talk about the solving of quadratic equations. Now, the quadratic equations can be solved by three methods. First, solving using the factor method, that is factorization method. Then we can solve using completing squares, and then we can solve them graphically. Today we are going to first talk about that method of factorization. So a quadratic equation is always in the format of ax squared plus bx then plus c is equal to a 0. Remember, when we talked about quadratic expressions, today we are talking about quadratic equation. An expression is different from an equation. The expression which was quadratic was of the form plus c. Then we are saying now the quadratic equation is of the form, that one. What changes the expression from the equation is that the equation has equal signs there, but an expression does not have. So differentiate between the two, that is the equation and an expression. So while factorizing the quadratic expression, we said we shall always need a sum, which is the one on the linear term, and then we shall always identify the product, and this one was a times the c there. Even here, solving the quadratic equation using factors, we are going to identify the sum and also identify the product. So even here we need the sum, that is positive b. Also we are going to get it from the linear term, just like the quadratic expression. We shall also need the product, and which is the same as a times c, just like the quadratic expression there. So when we identify the sum and the product, we shall get the factors, which give us a sum of that and the product of a times c. Then from there we shall have an equation which is of the format m times n is equal to a 0 there. So if we have that, we shall say that for m to be 0, that means that n was 0, or for n to be 0, that means that m was 0, or for the equation to be equal to 0, that means that both of them were 0. So we shall reach some stage after factorizing, then we say one bracket is equal to 0, or one factor, and also another bracket or factor is equal to a 0. A quadratic equation has its answers as roots. If they don't call them roots, they can call them solutions, as we shall be seeing when forming a quadratic equation. A quadratic equation has always two answers, simply because the degree of the variable is 2. That's why it must have always two answers there. The solutions to a quadratic equation, they can be the same, that is equal. For example, if the answer is 2 and another one is 2, they can be two answers when they are the same, 2, 2. They can be unequal, or they can be not the same. One of them can also be equal to a 0. My first example there, solve the equation x squared minus 3x then plus a 2 is equal to a 0. Now, when given questions, they can tell you that that equation is quadratic, or they cannot even tell you that that equation is quadratic. But for you, you must be able to see that such an equation is quadratic. How do you see it? We say look at the powers of the variables. We have x squared there, and then here we have x. So the square here means that the equation is 2 degree power 2, and that one becomes a quadratic equation. Another thing when solving quadratic equations, make sure that the right hand side is always a 0. If it is not a 0, first make it to be a 0. That is, take whatever is on the right hand side on the left hand side, such that you can remain with only a 0 on the right hand side. That's how you can easily identify the sum and the product. So our equation, we need to identify the sum and the product. Sum, we said we always get it from the coefficient of the linear term. That is, the linear term is negative 3x, and the coefficient there is a negative 3. So my sum is a negative 3 there. Then the product, we say if there is a coefficient there of x squared, you multiply it with the constant term such that you can get the product. So there is a coefficient of 1. 1 times anything is that anything. Therefore, we take the product to be positive 2. Now, we need to get two factors that give us a sum of negative 3 and a product of a 2. When factorizing the quadratic expressions, we say that those two factors come from the factors of the product. That is, you can list down the factors of the product, then identify them. Now, 2 is a prime number. It has only two factors, that is 1 and itself. So we are going to manipulate those two such that we can have a sum of negative 3, and then we have a product there of positive 2. So when I add negative 1 to negative 2, I get negative 3. When I multiply negative 1 times negative 2, I get a positive 2. So I'm going to get these two factors. I substitute them for the sum there. This is going to be x squared minus x minus 2x plus 2 is equal to 0. Another person can begin with the negative 2 when substituting here. That is x squared minus 2x minus x plus 2 is equal to 0. This person and that one, they differ less. It is just the arrangement of the substituted terms there. So the person who did this, when he factorizes out two terms, that is what is common there is x. So here I'll be left with x minus 1. Then this one here and that one there, I'm seeing that a negative 2 is common. So this x is going to be positive. Then that one is going to be minus 1 is equal to a 0. We said when you are factorizing, make sure that that step, when you open the brackets, takes you back to the previous step. So someone can ask, but sir, why don't you put here a positive 2? My aim is to make sure that this bracket here is the same as that bracket. If I don't take away the negative, this one is going to be a negative, and then this one is going to be a positive. And this bracket ceases to be the same as that. That is why I've factorized out a negative 2. So when I reopen the bracket, this negative 2 times positive x, I'll go back there to negative 2x. and when I multiply negative 2 times negative 1, I'll get a positive 2 there. So when I come back to this step here, you can see that this bracket is the same as that bracket, and we have just two terms there, which is the whole of that and this one here. So when I pull it out, or when I factorize this bracket, I'll be left here with x, then there I'll be left with a negative 2 into the bracket that I've pulled out is equal to 0. So this is where I said that we shall always be having a factorized expression in that form, and it is equal to 0. So here we're going to say, we said when we reach there, we're going to say that either m is equal to 0 or n is equal to a 0. So now here, either x minus 2 is equal to 0 or x minus 1 is equal to a 0. So from here you can find the two values of x that we are looking for. Here you can take the negative to the other side to become a positive. Then even here you can take the negative 1 the other side to become a positive. So we have the values of x there as 2, and another one is a 1 there. Example 2, solve the equation x squared minus x minus 12 is equal to 0. First, on the right hand side we have a 0 there. Then on the left hand side we are going to identify the sum and the product. We look for two factors that satisfy the two conditions, that is the sum and the product. Then we substitute them where there is the sum there. Then we factorize. So the sum is equal to negative 1. The product is equal to negative 12. We said factors come from the factors of the product, that is factors of 12. And those two, they are going to be negative 4 and 3. When you add them, you get a negative 1. When you multiply them, you get negative 12 there. So I pick them, substitute them where the sum has been. So this is x squared minus 4x, then plus 3x minus the 12 is equal to 0. When I substitute them, I attach the value of x there, because it was also attached to the sum there. I have 4 terms on the left hand side, so I'm going to factorize 2. So these 2 here, x is common. Here I'll be left with x minus here, the x has gone, I have now 4. Then here I'm having a positive 3 into here it is the x minus a 4 is equal to 0. So when you look at the first and the second example, here I've not factorized out the negative 3 simply because my bracket will not be the same as this other bracket here. We say these brackets, they should be the same, but when you're working out and you don't see that they are the same, please don't force them to be. Just know that there is a problem on the factors. Then first go back, check the factors whether they satisfy these two, then substitute again, and then everything is going to come out clearly. Coming back here, factorizing this bracket that is common. When I remove it from this term here, I'll be left with x. There I'll be left with a positive 3. Then into x minus 4 is equal to a 0. Then either x plus 3 is equal to 0 or x minus 4 is equal to a 0. So here, taking the negative for the other side, I have positive 4. Here, taking the positive 3 the other side, I have a negative 3. So we say that the solutions, they can be not the same, just like these ones. Those in the first examples, they were both positives and they were different. Here, one is negative and one is positive, but they are also still not the same. Example 3, solve for r in the equation, that one there. So the quadratic equations, they don't come in the variable of x alone. It can be different unknowns there or different letters. I know some people like so much the x writing x alone, x. For me, I don't like. That is why now I've used another variable there. So this equation, when you look at it, you may think it is not a quadratic equation, but when you cross multiply, you will see that it is a quadratic equation. Now I'm going to cross multiply. This will multiply that, then this will multiply that. The r into r plus 4 is equal to the 5 times. So when I put brackets and I put a figure outside here or a letter outside here, it means that this is multiplying whatever is inside the bracket. So don't get confused. Now opening brackets on the left hand side, r times r is r squared. Some students, for them, they multiply r times r and they get to r. Then I start wondering if they studied indices. Laws of indices: powers, you keep the base, you add the powers. So this gives you r to power 2, which I'm calling the r squared. So r times 4 plus 4r is equal to, when I multiply this side, I have 60. Now, remember when I said that make sure that there is nothing on the right hand side if you want to start solving. So we are going to take away this, bring it back to the left hand side. So this is r squared plus 4r minus 60 is equal to a 0. Identify sum and product. Sum is equal to positive 4. Product is equal to negative 60. Factors, they are going to be 10 and negative 6. When you add them, they give you positive 4. When you multiply them, they give you negative 60. So this one is going to be r squared, then plus 10r minus 6r minus 60 is equal to 0. Factorizing these first two terms, r is common. So when I pull it out, here I'll be left with 1r, then plus a 10. Negative is common in those two terms there, as well as the 6 is also common. So I'm going to factorize out negative 6 such that this should remain with r, then that term remains with a positive 10 there to be equal to 0. When you try to reopen, this takes you back to the previous step there. So factorizing further, because that and that, they are the same. So when I pull it away, here I'll be left with r, there I'll be left with negative 6 into the r plus 10 to be equal to 0. Either r minus 6 is equal to 0 or r plus 10 is equal to 0. Take 10 the other side, the value of r there is negative 10. I take negative 6 the other side, the value of r there is positive 6.